Hello everyone, and welcome to lesson 2-4, conditional statements and biconditional statements. So let's go ahead and jump right into it. Conditional statements are statements that can be written in if-then form. The symbolic form for a conditional statement is P implies Q. And that's read as if P then Q or P implies Q. So if P then Q, when we get into examples, you'll see it makes more sense. The hypothesis is the phrase that immediately follows if. So in the case above, P would be the hypothesis. The conclusion is the phrase that immediately follows then. So in this case, Q would be the conclusion of the statement above. Let's just go ahead and do a few examples. It'll start to make more sense. All right, identify the hypothesis and the conclusion of the following conditional statements. So in number 1, it says, if you live in Nashville, then you live in Tennessee. Now, of course, the hypothesis is everything following the if. So this would be you live in Nashville. And then the conclusion would be you live in Tennessee. Tennessee. All right. So anything that is the hypothesis is what's after the if. So if you live in Nashville, then you live in Tennessee. So that is our hypothesis and conclusion. There are a couple more examples here. If you'd like to go over those yourself, you can. So let's go down here. Write each statement in if-then form. So here it says, an obtuse angle has a measure greater than 90. So what we're going to do is we are going to create a statement that includes if and then. So what we could say is, if an angle is obtuse, then it has a measure greater than 90 degrees. Perfect. And you'll notice that in this case, we have this if, and we have this then, and we pretty much said the exact same statement, except for in if-then form. So this is all that we need to do for these sorts of things. So this is pretty simple. Conditional statements are the basic version of a statement, and we can do a lot of different things to conditional statements. So remember, conditional statements are P, if P, then Q. So let's look at a couple things we can do. So we can do a couple things to these conditional statements. First of all, we can take the inverse. And finding the inverse of a conditional statement, as you could imagine, is formed by negating the hypothesis and the conclusion. So if we were to do this symbolically, it would look like this. It would be if the opposite of P, then the opposite of Q. Or if not P, then not Q, is how you would look at this. And of course, that's the inverse. You're negating things. The converse is switching the hypothesis and the conclusion. So instead of it being if P, then Q, now it's going to be if Q, then P. And we'll do some examples, and this will make more sense. The contrapositive is the combination of the inverse and the converse. So in this case, we're negating and switching the hypothesis and conclusion. So in this case, it's if not Q, then not P. And we'll go over a few examples. We're also going to be able to figure out truth values and things like that with these as well. So we'll just get into a few examples and it'll start to make more sense. Essentially, all we're doing is we're going to apply the logic of these rules to our initial conditional statements. So let's look at this. Our conditional statement in this case is if it is Saturday, then there is no school. So we're looking at number 9, and it gives us this conditional statement. If it is a Saturday, then there is no school. Okay, that sounds cool so far, right? If it's Saturday, then there is no school. That sounds true. However, let's look at the inverse. So the inverse is if not, then not, right? So if it is not Saturday, then there, well, it would normally be there is no school. Then there, we'll just say is school, right? Because you're kind of taking the opposite. You wouldn't say no, not no school. That would be kind of weird. All right, so if it is not Saturday, then there is school. Is that true? Well, let's think about it before, right? What's a counterexample? What is one thing we can do to prove it, right? And it even says if false, provide a counterexample. This is definitely false. I can think of a day that there is not school when it's not Saturday, and that is called Sunday. So there we go. It's definitely not true, right? Let's look at the converse. The converse is when we flip P and Q. So if before it said if it is Saturday, then there is no school. Now it's going to say if there is no school, then it is Saturday. Now let's think about it. Is this true? If there is no school, then it is Saturday. Well, guess what? Sunday still exists. So this is also not true, right? Because if Sunday exists, then we have another day that it could be if there's no school. Now let's do the contrapositive. So we're going to take this exact same style as the converse, where we're going to flip the if and the then statement, parts of the statement, but now we're going to negate both of them. So let's do this. So if there is school, remember we're just kind of taking the opposite. If there is school, then it is not Saturday. Now, aside from, those of you who may get in trouble and have to stick around for detentions and things, normally we do not have school on Saturdays, so this is actually true. Hooray. Alright, so that's it. That's all we're doing. So when we take the inverse of a statement, we're negating both parts. When we take the converse, we are flipping the hypothesis and conclusion. And when we do the contrapositive, we're flipping the hypothesis and conclusion and negating both sides of it. And it's going to give us different truth values just based on it. And what's cool about these, as opposed to like the truth tables and things like that, is a lot of times you're just going to use your brain to determine whether or not it makes sense. So there's not really a mathematical contingency. It's more of just, does this make sense? Does this not make sense? So let's do another one. Okay, here we go. This one's interesting. So if the temperature is 25 degrees, then it is below freezing. Remember, and this is one thing I just want to point out, this is called our conditional statement. And you can almost think of it as this is like the first of the 4 kinds of statements, right? This here is actually, like, this is the conditional statement. Okay. Now we have 3 more statements. We have our inverse, our converse, and our contrapositive. So let's go ahead and see if we can figure these out here. So remember, the inverse is just taking the opposite, or the negation, of both parts. So if the temperature is 25 degrees Fahrenheit, then it is below freezing. So let's do the opposite. If the temperature is not 25 degrees, then it is not below freezing. Now, is this true? If the temperature is not 25 degrees, then it is not below freezing. Well, what about 26 degrees? Is that below freezing? I think if we know anything about science, it is. And assuming we're talking about water. Yeah, so 25 degrees, then it is not below freezing, is of course false. Oh, I forgot to put false. But yes, 26 degrees would be a truth value that would prove that wrong. Alright, converse. The converse, of course, is us taking the hypothesis and conclusion and flipping them. So instead of it being if the temperature is 25 degrees, then it is below freezing, it is going to be if it is below freezing, then the temperature is 25 degrees. Okay. So, is this true? If it is below freezing, the temperature is 25 degrees. There's actually many, many degrees it could be that are not 25 degrees that would still be freezing. So this is also false. And just for the fun of it, I'm going to also put 26 as the counterexample. All right, now the contrapositive is the inverse and the converse combined, essentially. Right? We're going to flip the hypothesis and conclusion, and we are also going to negate both sides. So in this case, it would be if it is not below freezing. Whoa. If it is not below freezing, then the temperature is not 25 degrees. Now let's think if this one makes sense. If it is not below freezing, which would mean it's above freezing, right? Then the temperature is not 25 degrees. Well, right. If it's above freezing, then it has to be above 35 degrees. So it's definitely not 25 degrees. So this actually makes sense. So this one is actually true. Now, there are going to be times when your conditional statement and your contrapositive are not true, right? So don't always think, oh, inverse and converse are false, contrapositive and conditional statement are true. That's not always the case. In fact, it really relies a lot of times on if the conditional statement is true, because if you have a false conditional statement, it's going to throw all the other ones off. So make sure that you don't just automatically assume that this is the case. All right. And there's a few examples up here that you can go over if you want to try a few more here. All right, but now let's get to these. So the next kind of statement is a biconditional statement. Of course, bi meaning two, conditional meaning, conditions. So there's two conditions in order for these two statements to be true. And the definition of a biconditional statement is the conjunction of the conditional statement and its converse. So if you look up here at these examples, right, you remember how we had our conditional statement and the converse. If both of those are true, then it will be a biconditional statement. And there are many examples of biconditional statements that are true, and we'll go over a few of those just to make sure. All right, so the symbolic form of this is, of course, it's the conjunction, right? So it's if P then Q, and if Q then P. And remember, they both have to be true. That's why it's an and a conjunction and not an or a disjunction. And the symbolic notation for this is, and I will show you that here in a second. The symbolic notation is, if I can get my pen to work, there we go. It's P, it's P, and then an arrow pointing both directions, and then Q. Because it's P if and only if Q. And you'll notice that that's what it says down here, right? It's read as if it is P if and only if Q. Now the truth value. Biconditional statements are true when both conditional and converse are true. And of course, that's what we said when we said the conjunction has to be true for the conditional and its converse. Both have to be true. It's not an or statement, it's an and statement. They both have to be true. All right, so the directions. Given the biconditional statement below, write both the conditional and the converse, determine the truth value of the biconditional, explain why it is true or false. So let's go ahead and look at number one. So it says here, it says two angles are supplementary if and only if the sum of their measures is 180 degrees. So let's look at what the conditional statement would be in this case. So here we have two angles are supplementary if and only if the sum of their measures is 180. So what we could say is if two angles are supplementary, then the sum of their measures is 180 degrees. That's the conditional statement. You'll notice that we rephrased this so that it has an if and a then. If two angles are supplementary, then the sum of their measures is 180 degrees. And that's true, right? So what I'm going to do is just over here, I'm just going to put a little t so that I know, right? Okay. Now the converse, of course, is when we flip the hypothesis inclusion. So in this case, it's going to be if the sum of their measures is 180, if the sum of two angle measures, we can make it more clear, is 180, then they are supplementary. All right. Now, is this true, right? If the sum of two angle measures is 180, then they're supplementary. Well, of course that's true. That's the definition of supplementary. So in this case, the conditional and the converse, no matter which way we put it, are true. So the truth value of this, of course, if they're both true, and it's a conditional, or it's a conditional conjunction, then this would of course be true. Awesome. So let's go down to, let's do number 3. All right. X squared equals 25 if and only if x equals 5. So our conditional statement will be x squared, and I'm just going to use this like caret key for x squared, equals 25, or no, sorry, if x squared equals 25, then x equals 5. Now, we got to think about this. Is this true? If x squared equals 25, then x equals 5. That's true, right? Because if we take the square root of both sides, x would equal 5. So we're just going to say this is true. Now let's look at it the other way, right? So we're flipping our if and then. So if x equals 5, if x equals 5, then x squared equals 25. All right. So if x is 5, then x squared is 25. 5 squared is 25. This is true. All right. So this would seem true so far, right? Everything seems fine. However, I kind of tricked you guys if you guys weren't paying attention to this. The conditional statement is actually not true, right? If we look here, it says if x squared is 25, then x equals 5, right? But what if x is negative 5? X squared doesn't only equal 25. X squared also equals negative 5. Or when x squared equals 25, x also equals negative 5. So this is actually false. Right? Remember that when you take the square root of something, it could be the positive or negative. So the truth value of this, because they're both not true, is false. Make sense? So false because conditional is false. All right, and that's really all there is to these. You just have to make sure that both of them are true, and if you do make sure that both of them is true, then you will have a biconditional statement. All right, well, there's a few extra examples on here if you want to take care of them. Go ahead and go into your exit ticket if you are finished, and I will see you guys next time.